joining us today for this live stream event. Before we begin, I'd like to quickly review 2 items. Our code of conduct. So the Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we just ask that you're mindful of your commentary remaining professional and on topic. So for today's session, we are broadcasting live to our Microsoft Reactor YouTube channel. If you've not tuned in before, this session will be available for on-demand access after the conclusion. If you'd like to engage in the chat and this is your first time tuning in, just be aware that you do need to have a YouTube account to interact there. So now is the perfect opportunity to do that. Which brings us to today's session. This is a 2-part series on Bicep. The first one is an introduction to infrastructure as code with Bicep, and we are joined by Stephane Lapointe to bring us through it. Let's bring Stephane up. Hi, how are you?
Hi, very good, and you?
Welcome. Thank you for hosting and putting these sessions together.
Yeah, it's my pleasure.
Super excited. I will let you step in from here. So just for our audience, please be aware the session will run for approximately 60 minutes with time for questions throughout. So again, if you have any questions, comments, feel free to drop those into the chat.
So yeah, thanks, Rebecca. My name is Stephane Lapointe. I'm a principal cloud architect at GSoft. I'm a Microsoft Azure MVP, and also I'm one of the core maintainers in the Bicep project. So today we will cover infrastructure as code. There's a lot of tools for infrastructure as code. One of them is Bicep, and it's this one we will cover. So why infrastructure as code? From my observation and a lot of people observation I've been able to talk with, most outages are self-inflicted. So that means people do a lot of manual intervention, manual configuration of the servers. Infrastructure as code has been more and more popular throughout the years, but still, when outages happen, it's because usually it's because of an error, a human error. So because people have been playing and tweaking settings, let's say in production and not in other environments, things like that. So this is what we call snowflakes environments. So like a snowflakes in winter, during winter, no one is alike. So doing little tweak here and there, it's very difficult to have environments that exactly look like, maybe except the size of the machine and number of machines, but for the configuration, etc. So again, this is one of the observation I made throughout the years, is that usually it's because of a human error or because we are tweaking things here and there, and it's not the same throughout all the environments. So that brings us to infrastructure as code. So I don't know how familiar you are with infrastructure as code, but one of the main advantage of infrastructure as code is that, as you can do with code for your software, where you have source code and you can build it, and you have an output, maybe some libraries, an executable, or something that you deploy on the web. The idea is to do the same thing with your infrastructure. So you define, let's say, virtual machines, you define a network, you define, I don't know, maybe a web app, a database, etc. So you define what you will need for your environment, for your infrastructure, and you get and you keep that definition static into a file in the definition that you have, and you can put that in your source control, exactly like your developers are what they are doing for the code. So whenever you are a developer, an IT person, you gain the same benefit that is present with DevOps, basically. So you can have versioning, you can have, and this is one of the last point on this slide. So versioning is it's made available and possible through source control. So you take your code for your infrastructure, you bring that into let's say Azure DevOps or GitHub, and from there you are able to do, let's say, peer review with your co-workers. You're able to do, so you can do PR on those infrastructure changes, so everybody is aware. There can be validation on it, so there's a process that can be there for your infrastructure, for the change in your infrastructure. So this is very great. One of the key aspects also is repeatability. So I was saying Snowflake's environment wasn't very good because it can cause a lot of problem, and having people tweaking configuration here and there, not always documenting what they are doing. So there's a setting in staging and it's not in production because we forget it, etc. So configuration as code is something, but it's very similar to infrastructure as code. So, but the idea is to have a recipe. You define exactly the state that you want for your infrastructure, and you can repeat that from environment to environment. The second point is introspection. So it forces you to really think about what you'll need in your environment before you do it. So it helps a lot into just keep things one at a time, and really think about what you want to achieve. That's in your environment. Do you want, let's say, something that is very secure? Do you need to be maybe, I don't know, SOC 2 compliant, etc.? So you need to ask you a lot of questions in order to put that down and reflect that into your environment and your infrastructure. So the introspection side of this is really important. So you think twice before doing just something in the portal, and when you set that into a static and into an infrastructure definition, it forces you to think about it. Having all those information into files also can act as self-documentation. So it's important for me, documentation, but I'm not too crazy about it, especially for things that are very technical, because often they get out of date, people don't come back to them. So what you will find in your infrastructure as code files is really the state that you want for your infrastructure. So it is by itself self-documented. And having that self-documented can also greatly help audits. So if I was talking about SOC 2 compliance, maybe you're going to want to be PCI compliant or ISO 27000. So there's a lot of places. It could be internal audit also. So the idea is that things are already in the source control. They are defined there in files. You add probably PRs made with your coworkers. So, and all those systems, whatever is GitHub or Azure DevOps or anything else you're using, all of this make audits very easy and a breeze if you want to show evidence, etc., etc. So I already talked about versioning. So let's switch to the agenda of today. So I just wanted to make sure that we are a little bit on the same page concerning infrastructure as code and why it is important. Now we are going to touch more the Azure side of it. So there's a lot of tools out there. We can think of Terraform, we can think of Ansible, we can think of really, there's a lot of tools out there. Today, I'm going to talk something that is very Azure specific. And we will go back to the root of what Azure is, so Azure Resource Manager. What is ARM? We will do a brief overview of this. We will touch the scopes, the deployment scope. We will see a little bit templates, parameters. We will talk about why Bicep. And after that, we will just be in demo mode, and we'll just dive in. And if you have any question at that point, feel free to ask them, and we might tweak a little bit the demo to fit your need if you want. So, Azure Resource Manager, what is it? What is ARM? So, as you can see in the middle, there's that control plane, Azure Resource Manager. This is that's the control plane, the management API you will talk to in Azure when you want to do any operation over your Azure resources. So on the left side, you see those CRUD operations. You could be using Azure CLI, Azure PowerShell. It could be HTTP request because you're using the REST API directly. Could be the Azure portal, could be VS Code, Visual Studio. Basically, it's any client talking to the management API of Azure. So in the middle, what we find is that control plane, Azure Resource Manager, is responsible for a lot of things in Azure. So tags, role-based access control, this is where you will set your permissions in Azure. And there's ARM templates. So before Bicep existed, there was only ARM templates. That was the native way to do infrastructure as code on Azure. You could be using scripting, let's say with PowerShell and CLI and Azure CLI. But if you wanted to have static and declarative way using templates to do that, ARM templates were the way to go. So on the control plane, what is also available, there are locks for your resources. There's also policy. So if you're doing governance in Azure, this is also the control plane that will be responsible to validate each request to make sure they comply with the policy you deploy. And also there's things like activity logs where you will be able to see what people are doing in your Azure environment and have a trace of this. So this is not just a restrictive list of what the control plane does. It's just to give you an idea. There's a few more things that is now in there, but so this is really the gateway between your clients, and after that, what we call Azure RP. RP are for resource provider. Think of them a little bit like drivers on your computer. You don't know exactly how to, let's say your computer doesn't know how to manipulate your printer, or how your mouse is working and how to interact with it. A driver is a middleman or a software in the middle that will take the request and know exactly the outward it's speaking to. So it's exactly the same thing with Azure resources. A resource provider, there will be one, let's say, for storage, compute for your VM, networking, if you're using app service, SQL database, Redis, etc. So there's a resource provider managing multiple type of resources for each of those categories. So your clients talk to the control plane, the management API, and that management API have logic in there, but it will pass eventually the message to the resource provider that will be doing the actual work in Azure for you. I was talking about scopes. Those are deployment scopes and assignment scopes. So the very base that you'll have in Azure, or the lowest level you can interact with are resources. So those will be VM, VNet, storage account, automation account, SQL database, databases, Cosmos DB, etc. Now you can have one or many resources. You will group them into a logical group that is called resource group in Azure. So think a little bit of resource group as directory, but they cannot be nested one under the other. So resource group will act as a logical container for resources in a certain location in Azure, in a Azure region, if you want. Subscription will have none, one, or many resource groups, and this is where usually it's not there. Usually, it's where the you'll put your credit card and where the charges in Azure will be. So you can have multiple subscription, and for each subscription, every resource under that subscription, the billing will be applied at the subscription level. So, but this is still a kind of a container for resource groups and a deployment level at that point also. Came a little bit later, the management groups. So think of management groups again as a logical group for subscription, because prior to that, you needed to go through each subscription, configure them one by one for RBAC policies, etc. Now management group is that and enable you to deploy, but also set things that will be flowing down in a hierarchical way, and with inheritance, to subscription, resource group, and resources. Okay, so that brings me to templates. So this is an empty skeleton of what template is in Azure. This is a skeleton for an ARM template, but you can see the different parts, and those parts still remain the same, mostly for Bicep also. That you will find the same ideas and areas in Bicep also. So you have parameters. This is what enables you to have dynamic templates. Think of them as inputs to your deployment. So without parameters, you would have to, let's say you want an app service to be called, app service 1, and the second one will be app service 2. Without parameters or either variables, those two are the one that make your template more dynamic, if you want. And so little things can change depending on the input you send this in, and you can compute values, etc., in variables and use them throughout your template. So parameters and variables are what make a template dynamic, if you want. After that, there's function. This is for ARM templates. Functions are not custom function and user-defined function are not there in Bicep yet. And after that, we find resources. This is actually the node that the core node that we have in an ARM template, and this will be what you mostly see in your in your Bicep file also. Outputs can be convenient if you want to think of parameters as inputs, and outputs will be your what you want to get out of your template and your deployment, so that it can be reused, let's say, by the script that is calling you, or it could be a deployment calling another deployment, a template calling another template, and you could use input and outputs to combine and do something a little bit more, let's say, complex for your deployment. Yeah, okay. So we have templates and we have also parameters. So just think it's just a way to express in JSON in JavaScript object notation. So it's a way to express in JSON the value for your parameters. So you could have a template with parameters defining them, and the parameter files can change, let's say, from dev, QA, staging, prod, etc. So you could have multiple parameter files that will be combined with your, or they will be specified at the deployment time at the same time as your template to change the value of the parameters you want to use. Okay, so having that concept with ARM, so why Bicep? I've been playing with ARM and ARM templates for a very long time now. I don't know, probably we're in 2022, probably 10 years. Not ARM templates, because ARM templates weren't there at that time, but playing with infrastructure as code, automating through scripts, and so doing a lot of PowerShell, Azure PowerShell, etc. ARM templates came a little bit later, but it was a big improvement, but still very complex. It was the learning curve was steep, and you still had to convince people to kind of grab that definition of the infrastructure through a JSON notation. Hey, don't get me wrong, it was working. It has this a little bit complexities and learning curve to have, but once you master that, it was very powerful. It is still very powerful, but the entry point and the easiness of learning this, it wasn't very that easy for teams to invest and grasp everything that was possible in there. So Bicep came a few years ago now, and it's an abstraction over ARM templates. Basically, what we are doing with Bicep is we have a definition, still a definition in that use the Bicep language, the way you express it. And what we'll do is we will transpile at deployment time. Transpiling is taking, let's say, the way you express your infrastructure in Bicep. We will translate that into an ARM template, and this is what gets deployed. So you don't have to write ARM templates anymore. Bicep is your new way to express your infrastructure, and the tooling and Azure will make sure that get transpiled into an ARM template, and this is what get deployed at the end. So Bicep is way more concise than ARM templates were. So you don't have all those accolades anymore. You don't have this JSON to express something. JSON is still way better, let's say, than if you're old enough than XML was. So it's more concise, but it's still very verbose and asks all those accolades and etc. So it's easier to understand. It's more concise. The dev experience is improved, and the learning process is really improved by that. There's no state. So if you've been using, let's say, tools like Terraforms, don't get me wrong, it get the job done. Personally, I have a preference for Bicep and ARM in general, but a lot of people are using Terraforms. We are using Terraforms where I work. We're using both Bicep and Terraform. But one of the things with Terraform is that they get an abstraction around Azure and the provider. Azure is investing in Terraform, so there's a good pace at which the APIs updates are reflected into the Terraform provider. But there's also the state. So since Terraform is not Azure, And the team in Azure, a few teams in Azure like to joke about that Azure itself is a multi-billion-dollar state machine, and they're right, because they know what the state of your resource are. They are hosting your resource. They are deploying and basically hosting your resource. So they know what state your resources have. So you don't have to keep a state file on the side and migrate that from environment, from a storage account to local, etc. So depending on how and the tools you're using, state could bring frictions and sometimes maybe frustrations. But yeah, it's still working. And but the thing is, with Bicep, there's no state at all to manage. And the API, I was talking about the API versions. So API versions for resource provider is what they come with version with supported features. So with Bicep, as with ARM templates, API versions are available day one. Not like, let's say, in other tools where they need to update the provider, update the code of it. So there's a delay between new features and when you get them. So again, tooling is a little bit more interesting, in my opinion. In Bicep, you have linting. And with Bicep, it's not all or nothing. So if you already invested in ARM templates, you can gradually bring them over Bicep. There's also, I'll show it a little bit later, there's an option to decompile an ARM template. It's a best effort, so it's not magical, but you'll see that it can bring an ARM template into a Bicep file, and with just a few tweaks, you have something that is already out there. So both can coexist, ARM templates and Bicep, with your deployments, and you have the option to gradually migrate your investment from ARM templates to Bicep. So with that in mind, let's dive in. I can see a few questions a few comments. So I don't know if most of them has been answered, I think, but I will.
Hey, Stephane. Yeah,
Yes.
the chat has been really engaged, but there's been some great contributions from
Nice.
across the board. They've been discussing the differences between ARM and Bicep and third-party things like Pulumi and Terraform. It seems like there are some knowledgeable folks out there that are assisting in the chat. So thank you all.
Yeah, I can see that. I don't see all of them, but I can see at least that Corey is kind of answering the question. That's greatly appreciated, Corey. Okay, so I hope everyone can see my screen okay. And let us know if the size is very big on my end, but let us know if I still need to maybe zoom a little bit so you can see better, okay? So this is a Bicep file. I just basically, it's an empty file. Where I'm in Visual Studio Code. I have the Bicep extension installed. So if I do a search for Bicep, I have already installed. There's an extension. So you can install that in Visual Studio Code, and you're good to go. So I just created a file main.bicep, and what I want to show you, we've talked about parameters, variable, resources, outputs, etc. So how is it in the real world? So we will stay basic, but still, I'll show you a couple of things. I was talking about linting, the experience linting. Yeah, sorry. I'll show you what it could bring for for experience, for example. So I created my main point bicep. What I'll do is create parameters. So it starts with the keyword param. Let's say I want to do a SQL password parameter. It's of type string. And let's say I want to have a default value. So I don't know, my secure password. Okay. You can see I have a little wiggle in there. And it says that my password is declare but never use. Okay. We can go back to that later. Since it's a password and every password or sensitive information you have inside your templates or in Bicep, even in ARM templates. Anyway, everywhere it's a good idea to never have sensitive information in clear directly into your deployment, especially inside your template, because that will end up in your repository and you don't want a trace of that until the end of time. So let's say for this one, I want to tell Azure that it's secure information, sensitive information. So my SQL password, I don't want that to be exposed in the logs, for example. So I'll define that as secure. And you can see now that it wasn't the case before, but now I have a warning saying that secure parameters should not have hard-coded value. They shouldn't have default values. So this I can control that, and I can remove that. So what's remaining is that the SQL parameter, the SQL password is not used. This is not something I need to. It was just an example to give you around secure parameters, and they don't want default value. And this is what a little bit the experience with linting is in Azure, in Visual Studio Code. So I'll just put a little bit down. So what we want to do, let's say we will start with with Bicep, there's a lot of pre-baked code that you can just invoke. So if I do, let's say, which we call snippets, so I can do res.app, and I can, let's say I want an app service plan. This is where you deploy your website in Azure. So I just do enter, and I have something here that is a little bit new. So we add parameters. Let's say I will have a param. I will call it environment code, and it's going to be a string. After that, let's say maybe I want a param for the location of my resources in Azure, and I will, let's say, set the default value for that to, there's a function that is called resource group, and this is where this is the resource group where the deployment is taking place. So one thing I didn't mention is that we can define, I was talking about scope previously, so management group, subscription, resource group. The only resources, we cannot deploy at the resource level, but those are still assignable scopes. But for deployment, it's resource group to management group, and we can also add tenant. The tenant scope is your Azure AD tenant. So let's say for the sake of simplicity, the scope for this template is going to be a resource group. So the location I have, and then I will, let's say, that's it for now. Or maybe what I'll do is I'll add allowed values for my environment code. Maybe I don't want people to enter everything they want for the environment code. I want to control that, so that I can have dev, QA, SDG, and then maybe prod. Okay, so, and yeah, the environment code is not used at that point. So now I have parameters. I still don't use variable at the moment, but I will do that just right now. So what I could do with variables is take, let's say, information I compute all by myself, or play with parameters to come up with static or computed value that will be reused in my template later on. So maybe I want to have a naming convention, and I want, let's say, to have a naming prefix. All right, and that will be okay. And if we want to deal with string in Bicep, it's those are defined within single quotes, and we can do string interpolation to reference other maybe function in Bicep, or maybe other variable and tokens, let's say, from Bicep. So what I'll do is I'll take maybe I'll say proj1, and I will do environment code. So the value for that variable will be proj1 dash and the environment code I get passed. So I could work with this, let's say, and this is my prefix. So what I'll do is I'll come up with a name, let's say, for my app service plan. Oops. Name, and what I'll do is put the naming prefix. So now I'm using that variable dash app service plan dash all dash maybe I didn't make that, but let's say I'll make I'll do a suffix also. So suffix, and from there I can say one of the function I can use is Unix string. So Unix string, I can pass multiple arguments to Unix string, and the result will be a computed 13 character long hash that is unique from the input. It's deterministic, so it will always be the same value for the same input I put in. So it's a good idea, let's say, to say, well, I could use the resource group.id. So this is the ID of the resource group. I'm deploying it. So the suffix will always be the same. It will always be the same 13 characters computed each time I deployed in the same resource group. If I deploy to resource group A, resource group B, the naming suffix will, the computed value will be different from one another. But and yeah, so let's say, so now my app service plan has proj1, the environment code dash asp all, and then this Unix string there. You need to make sure that you pay attention to naming, because you have a lot of different naming restriction from resources to resource. But this is, you get the idea there. So, okay, now I have an app service plan. Let's say I will do a res. It's going to be web app. Yeah, there's web app. So I have a web application. Again, I could have my app service name, which is going to be probably web default, whatever the naming convention you want to have. So as you can see, it's been a few resources I've been playing with. So the way you express resources is using the resource token. After that, you give it an identifier that could be reused throughout your template. And after that, you are expressing which type it is. So I was talking about resource provider. So Microsoft.web is a resource provider, and one of the available resources under this resource provider is server forms. Okay, now the names. This is for an app service plan, which is app service and the web app PaaS offering in Azure. Server forms comes from it's the name they gave it at the very beginning, and so it's not reflected with the actual name right now, but still it's there for compatibility. So, and after that, you have the API version. So if I remove that and want to target another API version, I could do Control-Shift, and I have all the list of available API version I could use for that resource type. So name location is always there. Depending on the resource type you're dealing with, you could have a SKU, which usually you will provide a capacity and what is the SKU name you want to use. This one is F1, it's a free one. We could use Premium V3, for example, for the app service plan. This is where you're going to define that. But again, you have IntelliSense control. I just did again Control-Shift, and this is where we get that. So basically, you get the idea of what we have in there. Let me just open because time is flying. Let's just say I have a complete example here with, basically I have the same parameters, a little bit more resources. I have an app insight, I have an app service plan, I have a web app, and I have an output. And in the output, you can see that I was talking about resource reference. I have my app insight component, which is here, and I can refer to this, let's say, in other part of my template. And let's say in this output, I'm saying, go get my app insight resource, get its properties, and from there, I want to use the connection string. So I will get that value that is available at runtime and will use that as an output. I'm also using the app insight component, going again in its properties and retrieving its instrumentation key. And this is just an example of setting an app setting on my web app against a value of another deployed resource. So my web app will have an app setting named app insight instrumentation key, and the value will be retrieved at runtime by Azure and injected in there. So let's say I want to deploy this. Let's just save this first, and we'll deploy my main point Bicep. So I do a AZ group create. I'm using Azure CLI, but you could use Azure PowerShell to do this. So AZ deployment group create. I'm specifying deployment the resource group I'm deploying into, the template file. This one is main point Bicep, and I'm providing one parameter value, environment code equal dev, and let's just do this. Again, I don't have to specify all the parameters because some have as default values. You can see location will by default take the location of the resource group I'm deploying into. And this is what the resource group function is doing, giving you contextual information around your the resource group you're targeting for your deployment.
Hey, Stephane.
And
yes. Sorry, I just wanted to take a second. I'm not sure if this was answered, but Corey in the chat asked, can you decompile between ARM and Bicep?
Yes.
I just thought that was.
Yeah, I will touch that in a second. It's actually on my list, so you're reading my mind, Corey. So the only thing I want to add on this is that you could get a very small or big Bicep template at this point. So you could see that, okay, this has been deployed. If I go back to the portal and I refresh my view here, you can see those 3 resources has been deployed, and I didn't have to touch anything in the portal to do that. And what is magic is if I need to go there, and for my QA environment, I deploy exactly the same thing. Just I change that to environment code QA, and then boom, I will have a new set of resources because of the way I'm playing with naming. Right now, it will be deployed in the same resource group. It could be and probably it will be another resource group and maybe subscription. But you are controlling the deployment scope at the time you're deploying. And this is what I do with resource group, let's say Bicep infrastructure as code in there. So getting back to my, okay, and that is done. If I go back there and refresh, you could see I will have QA. Okay, this is caching issue, but QA resources will start happening right now. Okay, if you have a lot of things in your Bicep and you want maybe to start to reuse the logic you put in there because you want to control how resources are deployed in your environment, and you have good practices. Maybe you have a cloud center of excellence, or you're just a few dev or IT person that have great skills, let's say, and wisdom to know how resources should be configured. You could pass Bicep file from project to project, but what you could do is also create modules. And modules is exactly the same concept as the Bicep file I just found. The target scope is the same. I have parameters, I have var, resources. The idea is you encapsulate the block you want to redeploy and share, let's say. And you could reference it instead of, let's say here I have a main.bicep, I have resource. What I could do is target module instead. And from there, I would call my module, let's say just test. And I have a list of directories I could go. It's in the underscore modules at the top here. And I could just do app service.bicep. And I can type equal, and from there I could go with the required properties. I have default values for everything in there, so there's nothing. Let's deploy, and you could see I could go with params, and I could override the locations, queue capacities, queue name, etc. So what you could do with module is start to build yourself an enterprise assets, if you want, for good practices you define in your ARM templates that you want to share across projects. So this is one thing you could do with module to promote reusability, and just don't do the same thing twice, especially when there's good practice involved. What you could do, this module is in the same project I have. So it's on the local file system with what I have here. So it's local to my machine. It could be in the same repository I have. Let's say if I have in Azure DevOps, I think the question would ask, where could I centralize my Bicep file? I think I saw that from the glimpse of my eyes. Yes, you could have a repo where all your Bicep files are centralized. What you could do if you are doing modules is create an Azure Container Registry, which in short stand for ACR, and you could push your enterprise assets, your enterprise module into that Azure Container Registry and reference it the same way you're doing module now. So what I could do, I already pre-deployed, okay, just for the sake of not having an error there, to do location equal Canada East, for example, and maybe it's not a. Okay, so I have my model there. I already deployed some artifacts, let's say, and I think I just did that. Yeah. What I will do is, let me just deploy that because I didn't do it. So what I'm doing right now is I already have a Azure Container Registry. I will deploy the Bicep file that is there inside my container registry, and I will be able to reference it after that. It doesn't need to be on my file system anymore. I could delete that file and say, I want to have my module test. BR is the Bicep registry. Column is the name of my ACR in Azure. And this is the path where I publish that module. And I could do exactly the same thing, except that but because I have another test there. And from there, I could do exactly the same thing I'm doing above, but this time the file comes from an Azure registry in Azure. It could serve the entire business, and you could put tags for versioning in there. So that's a great way also to leverage your enterprise assets and promote reusability. So to get back to the question of Corey, if I could decompile, if I have this Bicep file right now, I could build it to come up with an ARM template. So you have this syntax, which is more concise. If I build this, what Bicep is doing is it's transpiling, like I was saying. And you don't have to learn how to express all those escaping, new format, because I was using string interpolation, reference to all those variables. Bicep and ARM is handling all this during the transpile for you. So the end result will be that JSON file, but you don't have to care about that anymore. So I will delete that. But if you already invested in ARM templates, let's say I have here a resource group. I already made a deployment in there. So this is my deployment that was done. I could go get the template. I could download it. I could copy that, and let's say I will just put that into the reference template in there. Remove that, save. Yes. And from there, I could do, let me just copy the file, copy path, and I will do an AZ bicep decompile-f. So I'm doing AZ decompile-f for file, and this is a best effort. So we could get things not exactly as we want, but instead of having all this big template, I'm getting back to a Bicep file. But what I could do, usually the name, you probably want to go over it and maybe rename them. So I could go in there, and this is my unique resource name, for example. This is my key vault. Oops. And key vault, renaming that. This is an object reference for my website. Okay, let's just say key vault in here. My storage account. Okay, I have a wiggle here saying this is read-only. That happens sometimes when the template is exported in the portal. I can just remove that. This is my server form, so I can say my app service plan. I could have there my website. If I have any other error, I could see the name is not okay. You could see for this particular resource and API version, those are I cannot provide these. So I'll remove that, and the variable config, this is something else in my main bicep. It's not my template that is referenced anymore. So as you can see, from a few tweaks in my after the decompile, sorry, this is probably a shipping, and it will be eternalized in my session. So so with just a few tweaks, I was able to get an existing template I have in my source control. I could go with something that is already deployed in the portal, let's say, get the ARM template of it, get back, save that into a JSON file, or just downloading it, and we can decompile and work from there on that Bicep file and eventually incorporating it into our enterprise assets. Okay, so is there any question there? Because I could wrap up, and it's already 12:56. But there will be a second session. Otherwise, I'll put back also my how to reach me, and I think we'll go from there. And we could. And Sonix is saying it looks like a steep learning curve. If you've never done before infrastructure as code, it could be a little steep, but there's a great learning path on in the Microsoft doc for learning Bicep. So, and everything that is infrastructure as code related, the link is should be right now on your screen. So just a quick recap, the advantages of infrastructure as code. We talk about repeatability, introspection, self-documentation. It's in your face when you take a look at the declarative of let's say my Bicep file. I have this app service plan, I have a web app, I have app service. It's all self-documented in there. So again, for audit and versioning, I could put that into my source control, collaborate with coworkers for reviews. Advantages for Bicep: more concise than ARM, easier to learn. So Sonix, if you found that it was maybe a steep learning curve, don't desperate. Using the learning path, it's a great introduction. I think you're going to find it easy than just installing the plugin and trying to figure out how to do that by yourself. You will be guided using the learning path. So improve their experience, no state, API version available on day one. And after that, let's dive in. You have the linked https aka.ms/armbicep 5.18, and this is your shortcut to the learning path on Azure Doc. So let me just put that in there. Again, my name is Stephane Lapointe, Principal Cloud Architect at GSoft. Again, my Twitter is there. LinkedIn is also in there. So you could reach me for any question. If you have something you want me to, there's the issue and GitHub repo for Bicep. You could reach to me directly if you want something, you want to discuss about something about Bicep, or I could be the bridge, let's say, between you and the Bicep team also, if there's anything of value for you. So let me know, and thanks again for being with me this time.
Thank you so much, Stephane. I'm not sure if you answered this question, but I just wanted to call it out. Yeah. Someone asked, Corey asked, can you inject local variables into modules as parameters? Did you?
Oh, yeah, you could absolutely. So you could reference, let's say, the same way you could reuse, let's say, a variable or parameters you have in your Bicep file. You could pass any of these information into the parameters of a module. So you could get the parameters of your Bicep file into the parameters of a module. Same thing for variable or any properties of a resource you declare in your Bicep file. So let's say you have a module, and the example I had was an app service plan. I could use, let's say, a property of my app service plan and pass that inside the parameters of a module. So anything you have in this as information in the scope of your deployment, you could pass that information to as an input to your module. Yeah.
Awesome. Thank you. And then Sonic's added another question. Does this work only for Azure?
Yes, it does. So ARM templates and Bicep, this is Azure native and will work only on Azure. One of the things though is if you're using Azure Arc, you could use deployment to deploy things inside your company, let's say on premise. But using Bicep, you won't be able to deploy, let's say, to AWS or GCP. So tools like Terraform will allow you to do that kind of things, but not ARM templates and Bicep. This is purely Azure specific.
Amazing. And then I just wanted to call out, it looks like most of the other questions were sort of responded to, and then also you covered them in your presentation. I just wanted to call out, Aaron made a point earlier that I thought it sounds good, that if you go to deploy Bicep templates in PowerShell, just make sure that you're installing the latest Azure models.
Yes.
Because older versions will cause failure, so.
Yeah, it's already a good idea to always work with the latest version of either the APIs, the plugin in Visual Studio Code, etc. Be prepared maybe from time to time to have breaking change, but usually just go through the change log before you update, so you'll be aware of if you have any tweaking to do with your scripts, etc. Yeah.
Amazing. And I just wanted to call out that this session is being not repeated, but followed up by Bicep by example. So if you tuned in today and you want to learn more about Bicep, did you want to speak to any of the following session at all? I know we're a little bit over time.
Yeah. But what I can add very briefly is that today was let's say just a very high-level overview of what you could do with Bicep. Next time, it's next week, same time, same day, I guess, if I recall, yes. And so we will go over a little bit more what you find in the language. So maybe how you will do looping, or we will go deep into modules. I just showed that you could reference module, but yeah, we will do ACR again, giving better examples. I think next week it's probably 3 to 4 slides, and all the rest it's all demo and all practical. So I think people are gonna love that.
Amazing. Thank you for that. So whoever stuck around till the very end, thank you so much. Thanks for the engagement in the chat. This is, these live learnings are opportunities to ask questions in real time so that you can, help yourselves along the journey that you're on for learning more about different topics. If you're not familiar already with the reactor, if you just happen to come across this on YouTube, just note that this is part of our Reactor community planning. We put out content on a weekly basis, both virtually and in person at our locations around the world. So if you're not familiar, definitely check us out. You can find us on Meetup. And we look forward until the next one. Thank you again, Stephane. This was fantastic. I look forward to next week.
Yes. See you soon. Bye-bye. Thank you all for attending.
Take care.